Welcome to Pratidwani, where we try to humanize science. It is my delight, pleasure, and honor to welcome the guest on this particular episode, Samrat Mukhopadhyay. Samrat has been a friend, a mentor, and an outstanding researcher, and so many other things other than what I am just describing here. Samrat is an outstanding scientist and is a professor of both chemistry and biology, which is very important to note, at Indian Institute of Science, Education and Research, Mohali. And Samrat has had an illustrious career over the years where he has dabbled both in terms of biophysics, biochemistry, and also bringing some very important questions related to liquid-liquid phase separation in recent years. He's also done outstanding work on ultrafast spectroscopy, intrinsically disordered proteins, amyloids, prions, and membrane binding. There's so many interesting questions Samrat has been actually addressing via experimental science, and also through actually interacting and also editing journals. Samrat is kind of a researcher's dream, and also an excellent speaker. And I've learned a lot over the years. And it's my absolute pleasure to welcome Samrat on Pratidwani.
Thank you, Pavan. It's a distinct pleasure to be here, and what you are doing for the Indian science community is remarkable, and you are spending a lot of time on this. And I know this time has to come at the expense of other things that you do, and it's quite a remarkable thing. And at some point, it'll probably turn out to be an epochal sort of set of podcasts or videos, and which will probably uh, continue to inspire the younger generation, early career researchers, students, and what you're doing is remarkable. And thank you so much for having me here. Great.
Oh, my pleasure, Samrat. Samrat, one of the very characteristic aspect of your research career has been your strong roots to where you actually have originated from, and also taking it forward and really doing good science. So, in order to understand that, we need to understand your origins. Where were you born? What was your childhood? And what was the kind of education you went through? So, give us a gist of that part.
Sure. Thank you. So I was born in Kolkata, formerly Calcutta.
Hmm.
So, and I grew up in the suburb of Kolkata called Howrah. And my education was both in Howrah and Kolkata. And so during when I was growing up as a kid in the 1980s and the 90s, so I think the most influence really in the beginning came from my parents.
Mhm.
And I was quite influenced, inspired by both my father and mother. And my father, who was not a scientist, who studied law and commerce. And I think I'm the what you call as first generation PhD, first generation scientist. And but my father had an extraordinary interest in science.
Nice.
And he used to perform, I remember, some science, very easy to do science experiments using household ingredients. And that will invariably, garner enthusiasm and excitement. Very easy to do, very safe experiments, long time back. And also around that time, like many kids in West Bengal, I also started reading Satyajit Ray's novels. Of course, Satyajit Ray was world renowned for as a filmmaker,
mm,
but he also was a writer. And he created some remarkable characters, one of which was a fictional detective,
mm,
and the other one was a fictional scientist, Professor Shonko. Okay, so I grew up reading Professor Shonko's adventures, innovation, and he would travel around the globe. One of the things that I remember was Shonko and El Dorado. Okay, so Shonko had to travel to South America, São Paulo in Brazil, and I actually ended up traveling to Brazil, São Paulo, in 2022. And I was super excited that what I read in my childhood days about Shonku's adventure. And so that was, of course, very inspiring. And I was kind of very inspired by Professor Shonku. Uh, and so as a kid, I was kind of trying to think about being a scientist. And I was good at both physics and mathematics. And I was also kind of starting to like chemistry a lot. And then around when I was in my eighth standard, uh, I had an amazing chemistry teacher called Vimal Bose, and he was an amazing teacher. And then he really recognized my unusual interest in chemistry when I was growing up. And then, of course, I started liking chemistry much more than anything else. I also liked history, by the way,
mhm.
a lot. So at some point, there was a debate whether I would take up history or chemistry. But as time progressed, it was clear that I was going to take up chemistry. And and of course, it was also clear around that time that I would probably take up scientific career or teaching career in
Mhm.
chemistry. And of course, as you would probably imagine, uh, if you are a good student in those days, everybody wants you to study medicine or engineering. And my parents were no exceptions. And my father wanted me to study medicine, and everyone around me wanted to study either medicine or engineering. And I already made up my mind to become a scientist. I was tenaciously unwilling to take up medicine or engineering. And I had sort of obstinate determination to take up chemistry. And my mother, Namita Mukhopadhyay, uh, was a great supporter in my sort of taking up a career in science. And my father, I think I didn't mention the name, Ashok Mukhopadhyay. So although he wanted me to take up medicine, my mother said, okay, he should take up something that he likes. And therefore, I ended up studying chemistry honors uh, at Jadavpur University for my bachelor. So at Jadavpur University, I was even inspired by my chemistry professors. And Jadavpur also had a fantastic departments in physics and mathematics. And so I also studied physics and mathematics because at that time it was very clear that a solid foundation in physics and mathematics is important to do chemistry in the future. And I'm glad that I studied physics and mathematics very seriously to study chemistry. And then, of course, that helped me sort of later on to diversify into, chemical physics, physical
Mm.
chemistry, spectroscopy, biophysics, and so forth.
Wonderful, wonderful. So it also looks like you probably had a very good upbringing in terms of the support within your family. Uh,
Sure, yeah.
what was it kind of at
Yeah.
home? Yeah.
So, yeah, I think I'm glad you asked this question.
Mm,
So I was a voracious reader,
mm,
and I really liked, of course, as I said, Professor Shanko, and then there was Sherlock Holmes. Okay. And I was studying Sherlock Holmes quite an early age,
mhm.
and he became my hero actually. Creation of Arthur Conan Doyle, and if you remember the first novel, okay, A Study in Scarlet,
Study in scale. Yes, yes.
and there Dr. Watson
Mm,
uh, sort of was introducing Sherlock Holmes. It was sort of like a CV. What Sherlock Holmes knew, most of the things he wrote nil knowledge,
mm.
and knowledge of chemistry profound.
Yes.
And the way Sherlock Holmes was portrayed, he was actually an extraordinary chemist. And if you think about a scientist, all scientists, including you and me, are at the end of the day, we are investigators, right?
True, true.
So we have to investigate something. We have to construct hypothesis, test hypothesis, eliminate possibilities, zero in on something. So that's all of these things detectives have to do. And Sherlock Holmes was, of course, a great example. And then I also started Agatha Christie.
Mhm.
Okay. And I think reading such such novels and pieces, short stories, Hercule Poirot, Miss Marple,
Mm.
I had a wonderful, upbringing, sort of that sort of, you know, set the goal on to become to a scientist, chemist particularly. So that was really amazing. And as I said, I was also quite interested in history. In
Mm.
fact, my father had several amazing books. In fact, when by the age of 16, I knew a lot about Indian history, European history, and American history. And in fact, the names that one would normally not know,
Mm.
or their contributions, like George Washington, Benjamin Franklin, Abraham Lincoln, I knew about their contributions. I knew because my father discussed with me, and I also read many of the books my father had. So I think that was really a wonderful childhood I had. And I must thank my father, Ashok Mukhopadhyay, and my mother, Namita Mukhopadhyay, and also my sister, Shatarupa, who was also kind of growing up with me. And so I had a terrific, let me put it this way, I couldn't have asked for a better childhood.
Wonderful.
And that
Uh,
sort of funneled me into science and chemistry. And then I almost knew at that point that I was going to do chemistry. And I fought very hard with everyone to do chemistry. And I didn't take up medicine or engineering. And finally, that's how I ended up where I am today.
Wonderful. Wonderful. So,
Thank you.
Samrat, I'm always kind of, I'm always in awe uh, in the way in which you have been able to bring both physics, chemistry and biology onto single platform? Because I know you extensively work on biophysics and related topics, which we're going to come later on. Was there anything in your foundational years which really helped you to develop these kind of interests? Because I know you have, it's very rare to have somebody who is equally well versed in ultra fast spectroscopy and biochemistry lab. I'm talking about bench stuff. A lot of people have done. I have also done some rudimentary biochemistry kind of stuff, but hardcore physics during the PhD too. But in your case, I find that that all three aspects kind of combined in your work. Was that something which is part of your training, especially at the college years? I know Jadavpur University has excellent physical chemistry, and I can see the fantastic cover page of his JPC behind you. I'm just
Right.
curious because that is something I'm always, interested to know about.
Yeah, I think this is a great question again. And of course, I need to kind of sort of think about what I did. And of course, yeah, as you said, Jadavpur had a terrific chemistry department, organic chemistry,
Mm.
physical chemistry, inorganic chemistry. They also had very good physics and
Physics,
mathematics
yeah.
departments. And because when you are doing an honors, or today you would call as major, then you also have minors
Mm.
in physics and mathematics and computer science. And I had some terrific teachers. And I was very interested in mathematics
Mm.
from very early days. And my father actually taught me early mathematics. Okay. And in Jadavpur, I was able to connect physics and chemistry, of course, with mathematics a little bit, because you need a foundation of mathematics to understand physics. And then, of course, as they say, chemistry is physics of molecules, right?
Nice.
So I began to understand that. In fact, one of my professors told me, physical chemistry professors, that chemistry is physics of molecules. And then we had some wonderful teachers who taught thermodynamics, statistical mechanics during bachelor's, and fairly serious statistical mechanics,
Mm.
quantum mechanics, spectroscopy, and colligative properties, and chemical kinetics. And entire my life, I've been worrying about kinetics and dynamics because I've been fascinated about the time dependent changes, right?
Mm.
So that has been a common thread in my entire career, the time dependent changes, which is essentially chemical kinetics. And there are some really wonderful different types of chemical kinetics expressions. And so I was quite fascinated about the physics and chemistry interface. And I was also interested in biology because I had biology as an additional subject during my higher secondary. Uh,
Mhm.
so, so I was, and of course, I was interested in vitamins, amino acids, nucleic acids. And then I realized that biology has a lot of chemistry because all these are molecules of life, right? I mean,
Mm.
they're building blocks of life. And then I began to see the connection between biology and chemistry, and to be able to explain a part of biology at least using chemistry, and then you explain chemistry using physics. Therefore, there is a beautiful connection between physics, chemistry, and biology. And chemistry essentially is at the interface, right? It
Interface,
is
yeah.
a
At
central
center
science.
science, yeah.
On one hand, it interacts with physics. The other hand, of course, it interacts with biology or
Biology.
material science. Therefore, as a chemistry student, I thought I was poised to sort of connect physical principles, laws of physics, and to study, biology. But that opportunity came much later in my career to study biology. But I was always excited about biological questions, wonderful biological problems, which can be understood in terms of laws of physics and chemistry.
Wonderful, wonderful. This is fantastic to learn
Thanks.
about. So we're going to actually now move forward into the chronology, so to speak, and explore a little bit more about the epoch journey you really made. It is one of the remarkable stories I've ever kind of listened and read about, where you actually go and give your interview at IISc, and it is truly remarkable story because you had put a great thread in on X, formerly Twitter, and it really was one of the fantastic stories. So narrate that story, Samrat. It's a beautiful story. I want this
Thanks
to
for
be told.
asking me this. I actually posted this story on the occasion of 25 years of my journey to IISc, Indian Institute of Science, Bangalore. And I posted it in 2022. And the interview was in 1997, summer 1997. And when I was studying in Jadavpur, there were quite a few options to do masters in chemistry. Of course, one standard option was to remain at Jadavpur University and do masters. The other couple of options were like going to different IITs, like IIT Kanpur, IIT Bombay, and Kharagpur, and other places. But when my father wanted me to study medicine, and I did not want to do that, and I wanted to study chemistry, he said then the best place to do science in India, at least in those days, according to my father, was IISc Bangalore. So, right from that time, I was kind of determined to make it to IISc Bangalore, Indian Institute of Science Bangalore, for a program which used to be, still is, very coveted program called Integrated PhD program. So you are also associated with IISc and other Bangalore institutions. So it was a very tough program to get admission, and I really wanted to study at IISc Bangalore as an integrated PhD because you get to IISc at an early age. Of course, after masters, you can go for a regular PhD program, but to be able to go to a place like IISc when you are, 2021, 22, it was remarkable, right? So I thought that should be my goal. And of course, in those days, as you know, even now, I believe, they used to have, exam centers all over India, different parts of the country. And Calcutta had a center uh, in Calcutta University building. And it was my dream to make it to IISc. And my exam actually went very well. And I was absolutely certain that I would be called for the interview, on campus interview in Bangalore. And I booked my tickets, railway. In those days, of course, you travel on a train. And it was also not easy to travel from Calcutta to Bangalore. There was no direct train. So you have to change in Madras,
Mm,
now known as Chennai, and then take another train to Bangalore.
mm.
So you have to make reservation in two trains, and there has to be, proper time, some layover in Madras. So I waited, and the interview call letter never came. So I was wondering what was going on. My exam went very well. So the day, I mean, I used to have 3 day interviews, right?
Yeah.
Uh, in June. And the first day of the interview, I was very disappointed at home that, IISc was my dream place and I wouldn't be able to go there because interview started on that day. And sometime around 11 a.m., uh, doorbell rang. And a postman handed over a letter which appeared to be interview call letter. And I thought it was for IIT Bombay or something else. And then I opened it and it was for IISc Bangalore. And it must have been lying in different post offices. They were not, I mean, there was some delay. And then, so I had to reach Bangalore within 2 days, and it was super challenging right at that point because it takes about 36 hours to travel to Bangalore. And at that time, even for, well off, flying was not really very, sort of easy option. And I didn't even know that, Bangalore had an airport. And both my parents worked. So I was alone. My sister was there and my grandmother was there. And I decided to go to Howrah station. Uh, Within like 5 minutes, I decided that I have to take this chance now. And they were very worried. My sister started calling my parents. They are different location in the city, their offices. And I made a decision within like half an hour. I was out of my house and
Wow.
headed to Howrah station with my cancelled tickets to show them that I need a place to just stand on the train for 36 hours or two trains and then go to Bangalore. And my parents also came from their respective offices to Howrah station. And the train got delayed, so I had some time to sort of organize things. And
That is one time
finally,
where you are okay with the delay.
and that time I was quite okay with the delay because I had to talk to the officials
Yeah,
and
yeah.
get things done. And then when I entered the train and I was given a seat that I can sit there till Madras. And my co-passengers were very excited about what happened to me. And one of them happened to have studied at IISc engineering MTech, I believe, and he was in some job in Madras. And I said, "Oh, you're going to IISc. That's the top place. That's great, and you will not miss it. You have come to this point. Now it'll be fine." But what happened because of that delay? So I couldn't get the next day. I couldn't get the train from Madras to Bangalore, and there was a huge storm in Madras and there was a power shutdown. The entire station was like dark and huge storm, right? And I was just, running at night. It was like about 11 o'clock. I was running everywhere to find a train to go to Bangalore. And most of the trains actually left in the evening. And I found one train that was coming from Guwahati, Assam, stranded on a very dark platform, and there was no light because there was a power shutdown because of huge storm. And finally I boarded the train with my suitcase and backpack, and I couldn't find anybody. That train was also dark, there was no power. So the train started sometime around 1:32 a.m. in the morning, and I was really getting worried because next day is the last day of the interview. I have to be able to make it, right? And I was like, and the train started after after a little while when the rain stopped,
mm,
and then the train started and then it stopped somewhere. I think it stopped near a place called Katpadi.
Katpadi,
uh,
yeah.
and then I was really nervous. An entire night I was just looking how
Mm,
fast the train would move. But of course, the train would move on its at its own pace. And in the morning, I was getting very anxious, and finally, I arrived at the Bangalore Central Station around, I think, 8:45 or so.
mm, mm,
And my interview call letter said 9 o'clock. Now, of course, later I realized that they would have interviewed me anyway, even if I had reached. But at that time, I didn't know, right? I thought if I don't reach by 9 o'clock, I would miss the boat, right?
mm,
So then I took the auto, and the auto driver also understood that there is some urgency, and he started driving so fast. I get panicked, right, through that majestic area and to IISc, Professor C.N.R. Rao's
yeah.
circle, right, in the C.V. Ram
Yes, yes, yeah, yeah.
intersection. So I was like, and then I couldn't cross the road because it was a very busy road. I mean, it still is a very busy road. I was like, every moment was like, and I was thinking, why me? Right? And finally, I crossed the road, ran, and my interview was in the old organic chemistry building. With the suitcase, backpack, I was running from the main gate to the building.
Mm,
And then, of course, I entered the building. I was running out of breath. I was like, somebody gave me some water. There was some waiting room, right? I mean,
yeah,
other
yeah.
candidates were also sitting. So I kept my suitcase and backpack, and my name was called. And I went. And I was, of course, looking like a zombie, right? Because I was traveling for almost 40 hours. And I entered the interview room. And then, as they say, rest is history. So, and I made it to IISc, and I was absolutely excited. And I was like, that kind of excitement I never had before and also after. And I made it. I made it to my dream institution, where my father told me that if you are taking up science, you have to end up at IISc Bangalore. And finally made it for the integrated PhD program. And then, of course, IISc, being at IISc was a privilege, as you
Mm,
know.
mm,
And the academic ambience, the environment, stimulating environment, uh, the association, people talk science, extraordinary professors, and overall, and then I thought I was super lucky that I made it to IISc at a much younger age than one was supposed to be, right, as an integrated PhD. So I did masters, remarkable professors, and then and Professor Uday Maitra, who I would work with later, was he started taking a class on physical organic chemistry. Eminent organic chemist, an outstanding teacher. And I was like, wow, I never thought about chemistry like the way Professor Uday Maitra taught. And then within a few weeks to a couple of months, I almost decided that I would work with Uday Maitra, because he was doing organic chemistry, a little bit different kind of organic chemistry. Uh, you can call it as supramolecular, bioorganic,
mm,
a little bit of physical chemistry, flavor of physical chemistry, and bioorganic chemistry. So very quickly, I decided that I would do PhD with Uday Maitra, and absolutely amazing scientist, uh, and a great mentor. And there's so much to learn from him. And I was tremendously influenced and inspired by my own PhD advisor, Uday Maitra.
Wonderful. Wonderful. So,
And
if you can
yes,
tell a little bit about Professor Uday Maitra, your experience of working with him. He's a remarkable scientist and also a great science communicator. In fact, if you
yeah,
look up
absolutely. Yeah.
his Twitter and Facebook page, the kind of work he does, he goes to colleges, schools, and does
Chemistry
demonstrations.
is fun. Yeah.
Yeah, man, he's quite remarkable. I hope to actually have a conversation with him at some point of time. But tell us your experience of working with him a little bit.
He's an extraordinary chemist. And as you said, is also a great teacher, right?
Mhm.
So who could enthuse students, and very interesting way of looking at organic chemistry, and very analytical in approach, and very clear
Mm.
about how things should be done, and very methodical, and exceptional scientist, an exceptional teacher. And I was tremendously influenced by Uday Maitra. And the other thing that I was also quite amazed about, uh, he always, you know, told us that it's important to do things in certain way.
Mm.
Of course, certain way of doing things are always important, because if you have to if you have to pursue science for your career, then it's important to do things in a proper way. And also, his he often came to the lab and showed how to do experiments, as simple as how to run a column
Mm.
chromatography, right? So, which is very important for organic chemists. And he was exceptionally sort of driven and talented in terms of, in terms of communicating to his students how things should be done. And he did the hands-on, and then how exactly the experiments need to be done. An amazing knowledge in NMR spectroscopy. As you know, nuclear magnetic
Mm.
resonance is basically the almost like Sherlock Holmes magnifying
Meg.
glass for organic chemists.
Chemistry. Yeah.
And the way he would interpret the spectral data, and deduce the structure or the structural transformation or chemical transformation was truly amazing. And during my time at IISc, I was also influenced by many others,
Mm.
including Professor P. Balram, and of course, a titan of Indian science. I don't need to really introduce Professor Balram, uh, an extraordinary scientist, and asked really amazing questions throughout his scientific career. And I was always interested to do biology or biochemistry later in my career. So I could sort of relate my interest, because Balram was an organic chemist, NMR spectroscopist, made gradual transition into protein chemistry and more biophysics. So it was kind of like an obvious choice for me to have a role model like Balram. And I almost idolized him. And And apart from his science, and of course, I attended every seminar, every lecture he gave, and I was also taught by him a course called methods, physical methods. It involved, spectroscopy, NMR spectroscopy, circular dichroism, fluorescence, and so forth. Amazing teacher, great orator. And
You know
I,
what? I have taken that course.
okay. That's methods.
Yeah. It's on molecular spectroscopy. Yeah, I was one of the persons. He was. It was probably the last course he gave before he became the director. Yeah,
Oh, okay. So that was really an amazing course, right?
yeah.
Uh, and of course, I was quite, inspired by the way he spoke,
Mm.
enunciation, diction. Seemed everything was just perfect, right? I mean, you can't make it better. And then, of course, during my PhD time, of course, I did my summer project with Balram
Hmm.
before I did my PhD. And during the time I was doing summer project and then PhD, he, of course, wrote, uh, I mean, he was writing for current science,
Mm.
but then he, around, I think in 1998, when I was a summer trainee in his lab, he became the editor-in-chief
Mm.
of current science. And then he started writing very incisive, thought-provoking editorial
Editorials.
pieces. And and I was an avid reader, not just me, many of us, in fact,
Yes.
sometimes would go to IISc library and we would wait for others to finish current science editorial and then go and read it. Sometimes it was not easy during the daytime because everybody in the library was trying to read his editorial piece.
Amazing.
Uh, and so he is basically what one would call as sui generis,
Yeah,
right?
yeah.
One of a kind and an extraordinary person in all aspects. And there's so much to learn from him. The clarity in his thought process, in his presentation, uh, and the logic, and they were all really remarkable. And I've learned a great deal of things from Balram. And still, I tell my students to read some of these editorial pieces. Those are extraordinary treatises and still relevant. Some of the problems are still relevant. And you also get to know so much of history,
Mm, mm.
right? Even history of IISc, how IISc was born is an extraordinary history. And its first director was Maurice Travers,
Mm, mm.
right? And there was an article about Maurice Travers and how he was appointed the first director of IISc in 1909. Actually, William Ramsay was asked to become the director,
Mm, mm.
but then Ramsay proposed his own student, Maurice Travers, from London to come and become the director. In fact, Maurice Travers and Ramsay, they made some remarkable contributions in noble gases.
Mm. Yes, yeah.
So some of these things I knew during the time I was at IISc, and so so since I was also interested in history from my very early days, so Balram's article actually had a very interesting sort of combination of the science part and the historical perspective. So I tremendously enjoy it, and sometimes I still read them. So
Fantastic.
I was tremendously inspired and influenced by Balram all throughout. Uh, from my master's days, PhD days, postdoc, then as a faculty. So I have been extremely inspired and influenced by him.
What are your broad learnings from IISc days, Samrat? What did you really, take away from that place? Because I know it has had a very deep influence on you. But I
Yes,
just want to
for
know
sure.
what are the broad lessons you really kind of extracted from that time period?
I think one of the most important things was to learn how to do science for the sake of science
Mm.
and how to sort of interact with people uh, and discuss science. And IISc also, I mean, still, I mean, in my days also, uh, it was as important that you should be able to talk to people across disciplines like physics and biologists, and of course, other chemistry departments, material science. So that was, and also in the uh, students' halls of residence, we used to have friends from other departments.
Mm. Mm.
And then at a place like IISc, you discuss science. And in fact, for some time in my hostel, we had a discussion forum. So in the evening, sometimes we'll discuss different things like emerging things in those days, organic light emitting diode,
Mm.
uh, you know, Nakamura's some of those papers. Okay, some of the folks from
Mm.
who worked with Professor C.N.R. Rao, and they would talk about Nakamura's work, blue lasers, and some of us will talk about, organic chemistry, physical chemistry, spectroscopy, sometimes biology. And there was, I think, the academic ambience at IISc is unparalleled, and the sociology at IISc is also very unique. And I don't think in India, at least, there is a or there will be a place like IISc where you talk to people predominantly science. And then, of course, other
Those
things.
things.
Obviously, cricket was another thing to talk about, but not at the expense of science.
Thanks. Yeah. Yeah.
So that environment, and everybody was motivated by and large to do science. As you know, I keep saying this, hard work and motivation always defeat talent, right?
Yeah.
So, so that was very important lesson. And then you interact, how to interact with people in a professional, respectful way. One doesn't have to be acquiescent or obsequious, but you can always be sort of collegial, professional, uh, and there could be camaraderie in the interaction. So all of these features were there in the interactions at IISc, at least in those days, and I'm sure they still exist because some of these things, exist forever. They don't,
Absolutely.
and
Absolutely.
also the you could talk to many professors in a there was enough informal, you could go up to anybody and discuss. I was also very influenced by one of our professor, Biman Bagchi.
Mm. Mm.
He taught us statistical mechanics, and he also had a lot of influence because I was also interested in phase transitions in those days, and such kind of very academic people, very academic oriented people, professors, students, your peers, your lab mates or co-workers, they were very academic. I think that is something which is very difficult, to recapitulate or recreate a place like IISc, I think is very difficult.
Absolutely. In fact, I should mention to the listeners and also the viewers that I met Samrat in IISc for the first time. There was a nice talk he was giving just before leaving IISc, and I was just starting as a PhD student in a forum actually called a Sci Forum, and
Organized by
Samrat's,
students
yeah, organized by students.
in the
That's when
evening after
in
dinner.
the late night, not even evening.
Yes,
It's a post dinner
post
talks.
dinner. Yeah,
Yeah, that actually really had a very strong impression on me. In fact, subsequently, in a year's time, I also gave a talk there. It had a very deep impression on a lot of us because I used to also take a lot of courses at IISc, although I
that's
did my
right.
PhD at JNCSR. And it still has a very, very important impact on a lot of students who did their coursework and engaged with discussions with students there. The library, as you mentioned, it's a remarkable place. So, Samrat, we are going to expand this forward and broaden the horizon. Now, you got your PhD, have this foundational kind of principles of organic chemistry, and also good exposure of other areas. Tell us about your post PhD journey a little bit, and then we'll
Right.
come to the current research here.
Right.
Mm,
So when I was doing my PhD, as I said, I was very interested in what I was doing. I was working on bile acids.
mm,
Fascinating. These are steroids, and you have very, uh, you know, there are esoteric features
mm,
in the structure. And this is another interesting thing that I must say, that chemistry has this very interesting lingua franca, right? So if you draw the structures, anybody will be able to understand, even if you don't communicate in the same language. So this lingua franca of in chemistry is very, very interesting. So I was working on bile acids, different kinds. In fact, I synthesized a bile acid that is available in bird's bile called avicolic acid. So I was very interested in what I was doing. And I also, one of the compounds I made that formed gels, hydrogels. So I was doing all of that. And then I was also influenced by Balram, as I said,
mm,
because my future, I could see that I would do somewhat deeper into biochemistry or, biophysics. So I was interested in some kind of quantitative biology with my chemistry knowledge and also physics foundation. So I was very interested in going diving deeper into biology. And then, of course, at that time I did PhD in chemistry, and then I decided to have a short postdoctoral stint, uh, is to be called as visiting fellowship at TIFR, Tata Institute of Fundamental Research in Mumbai, with someone which we were collaborating, uh, Professor G. Krishnamurti,
mm,
very well known for his contributions to biological fluorescence, particularly time resolved fluorescence spectroscopy. And he's known to all of us as GK. So I basically wrote to GK saying that after my PhD, I would like to spend some time with you. And at that time, G. Krishnamurti, had a long-standing collaboration with Professor Jayant Udgaonkar,
mm,
who was already a giant in protein folding at the National Center for Biological Sciences in Bangalore, NCBS Bangalore. And then I saw the opportunity to fulfill my dream of studying protein folding, because protein folding had all the features that really excited me. You can transform from biologically inactive, unstructured state to biologically active, native, folded state. And you could study kinetics. As I said, time dependence, kinetics, they were very important in my research. So, how does a protein fold
Mm-hmm.
was a very intriguing question for me, especially in a kinetic, you know, mechanistic perspective, mechanism of protein folding from a linear sort of random coil, not linear, random coil to a well-folded state. And I was also very influenced by Anfinson's experiments. So protein folding was fascinating. And then I saw GK and Giant, they had an amazing collaboration asking some of the very important questions in protein folding using spectroscopy, using time resolved phosphorescence energy transfer FRET, how a polypeptide chain collapses, and then how does it go into a well-defined structure. So I was quite interested to do protein folding. And since I did some work on aggregation of bile acid derivatives I made, including formation of these gels. So before leaving Bangalore, before going to Mumbai, around the time I submitted my thesis, I went and met Jayant at NCBS. And Jayant asked me what I was doing because GK asked me to talk to Jayant before I was leaving Bangalore. So, and Jayant, I told Jayant I was working on aggregation of bile acids. And these bile acids actually form this beautiful mixed micelles. They're important for fat solubilization and so forth. So then he said, one of the proteins he was working on, which undergoes some aggregation. And at that time, people were very interested because it seemed like one pathway is the protein folding pathway. The other pathway is a misfolding pathway that goes into forming aggregates, different kinds of aggregates. The most interesting ones are those which form highly ordered aggregates called amyloid aggregates. So then I started my visiting fellowship at TIFR to look at how does a protein go to aggregates and form this amyloid-like structures using time-resolved fluorescence, actually time-resolved fluorescence anisotropy, which allows you to sort of look at the rotational mobilities and so forth. I was fascinated to do some of these things. And then around that time, I was also introduced to a class of proteins called natively unfolded proteins, which never autonomously would fold up into a structure. So they exist as sort of like an ensemble, rapidly fluctuating structures. I mean, of course, there are structures, but they are all rapidly interconverting structures. And some of them also go like alpha-synuclein, tau, some of them also go to highly ordered. So there is also a very interesting disorder to order transition.
Order transition, yeah.
Right? So there is physics, there is chemistry, and there is biological implications. So I was very interested in this kind of area. And then what happened was after about 8-9 months of my visiting fellowship, I was starting to think about my postdoctoral, another postdoctoral stint in the US. And I was primarily interested in femtosecond spectroscopy because now you can look at, I've done nanosecond, picoseconds. Now I wanted to go even faster and to look at chain water interactions. Very intriguing. Now you can ask the question how water behaves around the polypeptide chain. And around that time, Amos Zowell from Caltech, now late Ahmed Zawel,
mm, mm,
uh, published some very interesting, very intriguing papers on studying water, which, of course, Biman Bagchi had termed them as biological water, the water that's near the protein surface. And MS Zawel, with his femtosecond laser, was able to probe this protein hydration water. And I was fascinated that, that I thought at that time that it gave me an opportunity to study protein folding or protein misfolding going into amyloid structure by just looking at chain and water,
mm, mm,
solvation, desolvation. And so that was one aspect I was interested in. There was another aspect that was emerging at that point. I'm talking about end of 2004 and early 2005. So another aspect that was coming up was single molecule spectroscopy, single molecule FRET, by which you can study different conformations in an ensemble. Because any spectroscopic measurements you do, you essentially record the ensemble average spectrum. Whereas by doing single molecule FRET, you should be able to sort of look at different subpopulations that are there in the ensemble. So my another interest was to look at these subpopulations, how they undergo conformational interconversion, and finally, lead to some of these amyloid structures and so on. So I applied to two places. I wrote to MS Zawel
mhm,
and Ashok Dennis, who'd become my postdoc advisor later. And I proposed uh, two proposals essentially. One is femtosecond spectroscopy to study protein misfolding aggregation. The other one was to look at single molecule FRET to study conversion of disordered proteins. In those days, we called natively unfolded proteins or prions into self-replicating amyloid species. So Ashok, at that point, was an assistant professor, joined Scripps as an assistant professor, and MS Zawel had already got Nobel Prize 5 years before. So when I got both the offers, then of course it was another fork in the road, right?
mm, mm,
So what do I do? And of course, at that point, everybody around me, I was at TIFR at that point, everybody around me said, yeah, go to MS Zawel. He's a Nobel laureate. Will have a great career. And but sometimes you need to isolate yourself. Sometimes you have to be a little bit reticent
mm.
and listen to your inner voice. And that's precisely what I did. And then I thought at that point, single molecule FRET sounded a little bit more interesting. Both of them were very interesting. And Scripps, great place because I was trained in organic chemistry, for which Scripps is one of the top-notch places. And therefore, I decided to go to Scripps. And of course, many others, including my PhD advisors and my, um, in those days, my fiance, who is now my wife, Millie Bhattacharya,
Mm.
also supported my this unusual decision to go to an assistant professor, declining the offer from a Nobel Prize winner.
Now that is actually a gumption and also, a confidence in a way. It's very interesting.
And many of them at TIFR, many senior who were actually my well-wishers,
Mm,
they wanted me to do well, but they told me that I they didn't think my decision was correct.
mm,
And for a moment, when many of the senior people tell you that, I don't think you should be doing this, then in the back of your mind, you are kind of a little worried, right?
Mm, mm.
Because, I mean, today in hindsight, I can say, okay, I did the right thing. But at that
Yeah,
point, I
yeah.
was on a trajectory. And as I said, there was a fork in the road, right? I have to choose the option at that point, right? So fortunately, it worked out exceptionally well.
Mm.
And I headed to Scripps. Ashok Dennis, my postdoc advisor, who actually did his master's at IIT Bombay chemistry.
Wow. Okay.
Very
Okay.
familiar place, IIT Bombay, where we have lots of friends there.
Yeah.
And he did PhD at U Chicago, then postdoc in Berkeley, and then joined Scripps faculty. And so Ashok Dennis is an extraordinary scientist. He's almost like what you would call as a polymath.
Mm-hmm.
He knew exceptionally well physics, chemistry, and biological problems. Any biological problems, RNA interference, prions, cell biology, deeper aspects of cell biology, immunology. He was a voracious reader,
Mm.
a very talented person, and one of the most extraordinary people I worked with, and very humble, very down to earth. And it was such a great. And when I went there, the age difference was also not
Not
much, right? He
much.
was
Yeah.
a young faculty, and I was at that time, you know, early postdocs. So we had a very nice communication between
Communication.
us. We are almost like colleagues.
Mm. Mm.
And he taught me single molecule Fred how to do some of the experiments initially. And then something remarkable happened. So I joined Scripps and I wanted to work on prions, but I didn't know how to work on prions. And then I started working on a very interesting project to look at ribosomal assembly. So ribosome essentially is a complex of RNA and
Mm.
different kinds of proteins, very in an elaborate complex. And I was trying to look at using single molecule FRET, the assembly of ribosome. Uh, this was a collaboration with a, a very eminent scientist at Scripps, Jamie Williamson.
Mm.
So I started with that. Then what happened was I noticed a seminar announcement. And the announcement came from another giant, Jeff Kelly. And he invited Susan Lindquist from Whitehead Institute at MIT for a seminar. And the title of her talk, Susan Lindquist's talk, had a term called East Prion,
Mm-hmm.
which I never heard before. I knew human prion, mammalian prion, East prion, something very interesting. So Ashok and I went to attend the lecture by Susan Lindquist. Fascinating lecture. And while listening to Susan's lecture, I told Ashok that, can we ask Jeff for a meeting slot? We could do some great collaboration. And Ashok asked, and Jeff actually, on such a short notice, said, no problem. So he gave us a half an hour time to talk to Susan Lindquist. And Susan was a pioneer in heat shock proteins and East prion. And we talked, Ashok, me, and Susan, we talked for like half an hour, set up a collaboration. And that changed my life. I'm forever grateful to Jeff Kelly. And this is also important for people to attend seminars. And then, of course, what happened, I we started a collaboration. So I made multiple visits to Susan Lindquist's lab at MIT in Cambridge, USA, US Cambridge. And then we did some very beautiful work on, looking at protein conformational dynamics, East prion domain dynamics using single molecule FRET. And the term intrinsically disordered protein was not yet coined.
Fine.
We called natively unfolded. That was to be coined in 2008, a year after my first paper was published. So my postdoc paper was one of the first demonstration of conformational dynamics using single molecule FRET of an intrinsically disordered protein. And I learned so much from Susan Lindquist, an extraordinary scientist. She passed away a few years ago. Really a trailblazing scientist, and absolutely remarkable scientist. And I was really fortunate to work with both Ashok and Susan Lindquist. And I must thank Jeff Kelly. I mean, without his invitation, this wouldn't have happened.
Superb, superb. This is a very fascinating thing.
Thank
It
you.
also is such an kind of a broad umbrella of questions that it really requires deep interest and also a commitment towards a research problem. In fact, that is something which is not very easy, and it's always a very important lesson as researchers one has to learn that that commitment to problem. It's not like a day or two. It's something I know that you have been working on some problems for ages.
Long haul.
Long haul, exactly. Wonderful. So, Samrat, this is a question I ask everybody. Why did you come back to India? I'm very sure you would have had opportunities to probably work
Sure,
somewhere
I
else.
had.
Yeah.
So let me tell you right off the bat that I love being a professor in India and at IISER Mohali. And I was talking to some of my colleagues because I draw inspiration from Balaram. I should probably start writing some articles. I think one of the articles would be why I love being a professor in India and at IISER Mohali. So, one of the reasons, of course, is you are in your country. And what I've realized also over the years that you can, if you do well, and if you can motivate, you can get really talented students in India.
Absolutely, you're right. Yeah.
And they're very, deep commitment to science and very hardworking. They want to also, leave their mark in science. And I'm sure at any IISER, IISc, TIF, any place for that matter, IITs or any universities, you actually get motivated students, right? And there is also enough freedom, academic freedom.
Yeah.
Nobody tells you what to do, and you are driven by your passion. And then I joined IISER Mohali. Of course, you can sort of relate to this because you also joined a young institution. When all of the faculty were young, they just returned from different parts of the globe and joined the faculty. And therefore, there was a lot of, I would say, it was a stimulating atmosphere when we started. Still it is. And a lot of discussion because we are all like senior postdocs returned to India. And of course, I had quite a few opportunities in India in different institutions, as you could imagine. So, and also another thing that I liked which I'm going to articulate in my article at some point whenever I get a chance to write it. I think the campus life that we are very used to is an extraordinary thing,
Yeah.
right? Because you live on campus, students live on campus, you have enough flexibility, and you also have, an academic atmosphere
Mm,
on campus. And it is definitely a privilege to be at a place which has a campus, which has its own sort of little town, right? And during the time when I returned from the US to India, uh, a few years before I returned, and at that time, IISERs were all in their infancies, and a lot of excitement was visible. And our founding directors in all IISERs were very dedicated
yeah.
to sort of take the institute at greater heights because they were all like, like their own babies, right? And many colleagues were also involved in sort of uh, shaping the institute's
Institution.
future. Uh, Fascinating time. I joined the faculty of IISER Mohali in the end of 2008, uh, and essentially, January 2009.
Mm, mm.
So that was a very different, very exciting time for us to be at a place like IISER. I think you joined a few years later.
Yeah, 2010. I joined in 2010. Yeah,
Yes, a couple of years later. I
yeah, you're
mean,
right.
less than a couple of years,
Yeah.
2 years probably. So I think we must. I must say that I was really fortunate to be able to make the right decision at the right point. And you always have forks in the roads, right?
Mm, mm.
And you have to make a decision, and you can't go back, right? So, and it's important that in all of this crossroads, you make the right decision. And you know whether you made the right decision at that point, right? It takes a long time for you to realize when you sort of look back on your career trajectory, then you realize that you made the right decision. Because it's not very clear, because it's like, you can't see things that just happened, right? It's very
Absolutely.
difficult to make an assessment, and
Assessment.
that's why history is such a great subject, because you need a few years to 10 years to 15 years to sort of reflect on what you did, whether you could have done things differently. But for me, I've also posted on Twitter some weeks ago. I would say that, if I were to do all over again,
Mm,
I would do exactly the same.
exactly. Wonderful. Wonderful. Super. That's actually a remarkable thing. So, before we also kind of come to the concluding aspect of the discussion, I would want to also get a gist of your research, which is contemporarily going on in your group. I know you also mentor a lot of students, and
Yeah.
they have all been doing excellent work by themselves, motivated by great training and also mentorship you would have got. I would have given to them. I want to get a gist of your contemporary research questions and also, the overall, the
Team.
buoyant group which you have built, which is actually quite remarkable. And I would want to also just get a few thoughts of on that. Yeah.
Yeah. So I must say again, I've been truly fortunate to have had really talented students in my lab. 14 students have already graduated, 15th already submitted her thesis, and maybe in a month or two, she will defend her thesis. So, and all of them were highly talented, very motivated, and I think it is important to ask the right questions.
Mm-hmm. Mm-hmm.
And what we do in the lab is essentially curiosity-driven research.
Nice.
Uh, and then you ask questions, you do some experiments, and they construct a hypothesis and then test the hypothesis using many other experiments. And sometimes we also develop, like your lab, or adapt at least some methodologies which will allow us to do things a little better.
Better. Yeah, nice.
And some of our aspects, especially in the last few years, we have done some interesting ways of doing Raman spectroscopy, single molecule FRET and HOMO FRET, or energy migration FRET, to study the condensed soft matter properties, right? And the work that we are currently doing at this point, or maybe for several years now,
Mm-hmm.
it is a true cross talk, sort of like cross disciplinary between physics, chemistry, and biology.
Nice. Nice.
So we are looking at phase transition, protein phase transitions, and trying to understand how some of these proteins, these are primarily intrinsically disordered proteins, they don't fold up, so they have multivalences decorated on the polypeptide chain, and they can sort of interact with a multitude of molecules, multitude of their own type of molecules, different types of molecules. We call it as heterotypic, homotypic interactions, and they can form this extraordinary materials, mesoscale materials, viscoelastic materials called condensates. Fabulous, sort of exciting interface between physics and biology. And of course, the time scales are so important, right? So when you're talking about mesoscale properties, condensed matter properties, and what's the time scale you are talking about? So time resolved spectroscopy becomes very important. Super resolution imaging, single molecule imaging becomes important. Then you try and understand how these kind of condensates that are formed via phase separation, macromolecular phase separation, are now driving biological processes.
Mm-hmm. Mm-hmm.
Like stress granule formation is very essential for the cells to survive under stress condition. Or there are other membraneless organelles in the cells which are super critical. And if anything, the material property becomes very important. The mesoscale property becomes very important, because if the interactions are weaker, then of course you will have more viscous, less elastic. If the interactions are stronger, then you have viscosity component. If you do, let's say, in terms of rheology, then of course it becomes more solid-like, right? Because it's more elastic. So there is an interesting sort of balance between viscosity and elasticity components. Essentially, the material property that drives biology. Fascinating, right? Any change will alter biology. And can we study the changes? Can we actually sort of look at the fundamental sort of molecular interactions, molecular grammar that dictates the material properties, which in turn sort of drives biology? So it's a beautiful connection that we are trying to sort of investigate, how the molecular sort of language translates into a nanoscale and mesoscale properties, and that drive biology, or that control biology in some sense. And we have some very exciting results and also ideas now to sort of study this very interesting molecules to different, sort of length scale and time scale, sort of how we can study this using different length scale, different time scales, and how they essentially translate into functions and dysfunctions which are involved in disease, wide
Super.
range of human diseases. So it's a perfect amalgamation of physics, chemistry, and biology. So
Nice. No, it's very fascinating. That is one thing I really admire about the kind of plethora of problems, which actually can be addressed within this larger umbrella of understanding proteins, especially the disordered proteins, protein folding problem, and there's so much of beautiful statistical physics in it.
yes,
That is a
absolutely.
that's there's a rich kind of tapestry of problems
Tapestry
which
of
actually
problems.
problems which
Absolutely.
can run through. The other point is also that you use extensively a lot of optical techniques. I know you have
Yeah.
done some fantastic Raman scattering experiments on those
Thank you.
droplets, that beautiful work. I really admire that part of work because I can understand a little bit more of
Thank
that.
you.
The other chemistry part and other things, of course, my knowledge is limited on that. But nevertheless, I really feel that approach, that enthusiasm is something which not only keeps the boundaries of that particular research area being pushed, but also motivates a lot of people whom you take along, because I know a lot of people have done remarkably well. A great representation, Samrat. I should mention that it's not only I mean, that is one good thing about also students who study biology, because the gender gap is lesser. But I also see that you have been encouraging as so many of the women scientists to really go up and do well. That
Thank
is
you.
something remarkable, something
Yeah, so
really.
out of 15, I think 12 were probably women.
Wow, that's a remarkable number. That's a remarkable number. Really,
Thank
one should
you.
appreciate that. Should really appreciate people who are listening, fellow scientists, students. This is something which you should really be noticing. That is a very, very important point.
And also, my first student, Neha Jain,
Hmm.
is now an associate professor at IIT Jodhpur. She's also doing exceptionally well, and I'm so proud of her.
Super.
And and she's doing well because of her, not because of me.
Me, yeah.
So, and I'm very proud of her, and I'm sure there are other who will soon take up. There are many others who will probably take up positions fairly soon.
Wonderful. Wonderful.
So I'm very excited about my students. Actually, you realize that as you sort of become, as you go along your
Along.
career trajectory, you realize that the success is not about really you.
Hmm. Hmm.
And you succeed because a lot of people are supporting. And in turn, you have to also make sure your students succeed in your lab. They remain motivated, right? And they remain inspired. Uh, and it is our job as an advisor, it's my job to have them motivated, yet have a good life, right? And you can do this very well if you manage your time. You can do well. You can have a good life. PhD students, I always think PhD students should have very good life,
Yes. Yes.
and they should be free. I mean, we all enjoy. I mean, we are doing science because we enjoy doing science. Therefore, we shouldn't aim at something that takes away our enjoyment.
Enjoyment. Absolutely. Absolutely.
And that is something which I think all of my students truly enjoy doing science. We interact, and we probably already know that we have a very sort of flat, non-hierarchic
Yeah.
structure and very informal, which is very important. And there is, I mean, there and their best output comes when they're happy, when they know they're in a supportive environment. So even if all of us would like a supportive, collegial, respectful environment, right?
Absolutely.
That's very important. And and many of these factors actually sort of play a critical role in the science one does, right?
Yes. Yeah.
And it is not just about the anybody, so whatever we call is a success, it's essentially a collective thing.
Mm.
It is never just one person doing something, right? At least today's science is very collective. And it is also important that students are trained, they do well at different places. They should have good training, good communication skills, interaction. As I said, interaction is very important to find a balance between, professional, uh, collegial, professional, respectful, and not being sort of, as I said, obsequious,
Yeah. Yeah.
right? That balance is very important, right? So, so that is so I think these are all part of the training during PhD, and
Absolutely.
I'm super proud of my students, I have to say.
Super. Super. So nice to hear that. That's an important point.
Thank
So,
you.
Samrat, we have almost come to the end. So,
Okay, thanks.
I would request you to, tell a little bit about your futuristic plans. What are your kind of exploring? What are your kind of directions which you would prefer to take? And
Yeah, so it's very hard to predict future, as you
future.
know. So people who have made predictions, they've miserably failed. But all I can tell you is my students and I are exceptionally excited about science, and we have fun doing science. And the current questions that we are asking are of great importance, and we are very excited about those questions, especially sort of the, how the molecular, nanoscale, mesoscale, and then biology are connected, right? So we're very excited about that. We also like to develop tools, methodologies, spectroscopy, imaging, biology, cell biology. You know, we're not limited by any other disciplines. We want to collaborate with people, which we are doing. And so I think one of the important things to understand what we are, what's the connection, what's the thread, can we understand that well? And if possible, in the future, can we have some of this science sort of to a translational direction a little bit? But that's not something which we will push forcefully to do translational research. But if it naturally comes and it takes that direction, we'd be up for that. And we are looking at some interesting, of course, we have been discussing in the lab with my students to look at some transcription condensates.
Mm.
So they're very important in cancer, particularly pediatric cancer. So some of these condensates actually, turn on the transcription and the wrong condensates, aberrant condensates. So is there a way to sort of regulate such things? These are fundamental questions.
Questions, yeah.
But if we're able to regulate, if we have some small molecules to regulate some of these things, then we can have a translational direction. So that's how I guess science goes, right? I mean, you do science for the sake of science, what you might call as blue sky
Blue
science.
skies. Yeah. Yeah.
And then, of course, it takes sometimes a natural direction and it gets funneled down into something very useful. That would be great if that happens. And if we're able to do some, if we go into that direction, at least a component of our work, if we can push it to that direction, that'll be quite exciting. But as I said, I can't predict future. And I'm also a person who lives in present,
Mm.
in the moment, like seize the day, and and of course we have to work hard. And borrowing from one of the iconic songs sang by Kishore Kumar,
Mm.
"Aane wala pal jaane wala hai."
Oh,
So we have to do things now, right? So life is calling.
beautiful. Beautiful. Absolutely. Absolutely. Well. Uh, in fact, Kishore's songs actually resonate a lot with a lot of philosophical aspects of
Absolutely.
how we live in India, and generally
Absolutely.
speaking, as a researcher too. And
Absolutely.
Samrat,
Particularly my
this.
favorites, one of my favorite songs is Zindagi Aa Raha Hoon Main.
Mm,
And and that was also quite special because this in the movie this song was also sort of the screen the movie it is in the Kabban Park area of Bangalore.
Bangalore.
Yeah,
Yeah.
it's a very inspiring song. And yeah, so we have to basically do well. And as I keep saying that you know we have to be positive and don't let your life be dictated by nitpickers and detractors. Avoid them, smile, and walk away, and be positive. Do your job, and that's it, I think.
Wonderful. That's a great note to actually end. In fact, that's something which a lot of people will carry with them, and kind of a take home message, so to speak, from this whole discussion. Samrat, it's been a remarkable kind of conversation. I
Thank
really
you.
enjoyed.
I also enjoyed the
Yeah,
conversation, and thanks for asking some really great questions. So, in any conversation, questions are very important, right? So,
absolutely. Just like research.
exactly, absolutely. You have to ask the
Yeah,
right
right
questions,
questions. Absolutely,
right? And
absolutely.
there will be answers,
Answers,
right?
absolutely. So that's one remarkable aspect. Ever since I met you long time ago, several what almost 2 decades ago, in IISc, there was already a very strong and positive impression on me, because I was just starting my
Right.
PhD, and you were finishing, and you were kind of moving forward. And I find that kind of exchange of ideas, and also inspiration one can actually leave on young people is sometimes is not captured in any metric, but it actually has probably all encompassing kind of notion. Yeah,
I think
that's
you,
true.
you have really articulated
Uh,
this very well. And of
mm,
course, today I was also able to speak about some of the people I've really been
mm,
inspired by. Uh, so as you can imagine, Bangalore, IISc Bangalore gives such an extraordinary environment. And that's where we met
yeah,
uh,
yeah,
more than 2 decades ago. So you can imagine the impact of IISc and also, JNCSR. In fact, I was also associated with
yeah.
JNCSR. But during my PhD,
PhD, yeah,
I
yeah.
collaborated with Professor C.N.R. Rao.
Mm,
So the environment at JNCSR is also really stimulating and very academic. So I think the environment matters a lot, right?
absolutely, absolutely. Thank you, Samrat. Thanks a lot.
Thanks,
I
Pavan. It was a pleasure chatting with you, and all the best. All my good wishes to you for your beautiful work you're doing,
Thank you.
scientific and also your interviews, which are really terrific and great contribution. Thank you so much.
Thanks a lot. Thank you very much, Samrat. This is Pratidwani, where we try to humanize science. This time, the one and the only Samrat Mukhopadhyay. Thanks, Samrat.
Thank you.